Hi, I'm Michelle and I'm a program facilitator at Power to Be. And something that is interesting about me is that I have a degree in biology and environmental studies from University of Victoria. So I thought that I would show you some of the intertidal zone that I've been living around for the past little bit. So I've been living on a boat and I'm very lucky to be able to get to explore the intertidal zone. So I thought it would be a really great time to show you guys some life that we have around here in Brentwood Bay. So some of the groups that we're going to explore today are arthropods. So arthropods are insects, but in the ocean they are crabs or lobsters or barnacles, so anything with a hard exoskeleton usually. We're going to look at cnidarians. So cnidarians are corals or jellyfish. And they all are held together because they have certain things called cnidicites, and those are stinging parts of their body. Then we're looking at echinoderms. So echinoderms are sea cucumbers or sea stars, and these are all radially symmetrical. So if you look at them, they're all symmetrical in kind of a circle form. We're also going to be looking at mollusks, and they're my personal favorite group. So mollusks range from clams or mussels all the way to octopuses, so they can get very different. And then there's some other groups as well. Annelids are segmented worms, platyhelminthes are flatworms, less exciting, and porifera, so that's some sponges as well. So these guys are ochre stars. You've probably seen them on the coast before. They're quite common. They come in purple or orange. And science is unsure why exactly they have those two very different colors. It's an example of something called phenotypic plasticity. So what that means is that even though they're the same species, they're able to change certain things about them. So just like humans, how we have different skin colors, so do starfish. So it's kind of neat. And so they're radially symmetrical, and they have 5 arms. And they have a spiny kind of hard outside, and their mouth is on the bottom of them. And so to eat, they are able to evert their stomach. So they usually eat mussels or other bivalves, so things with 2 shells. And how they do that is they have these things called tube feet. So they stick out from the bottom of them, and they are able to pry the shells open and put their stomach inside the animal, digest it, get all the nutrients, and then take their stomach back in. It's a very interesting way of eating. And how they move their tube feet is something called the water vascular system. And the best way to explain that is if you took a long balloon and you filled it with water, if you squeeze one end of it, the other end is going to get a lot more pressure and be able to move. And so that's kind of how they're able to move. It's kind of movement of water all throughout their bodies. So that's how they've adapted. And so ochre stars are actually really important in the ecosystem. There's something called a keystone species. And so what a keystone species is it's an animal that has a disproportionately large impact on its ecosystem. So if we took out all the ochre stars, we would find that this beach would be covered in a lot more mussels. And what that would mean is that there would be less room for other animals to be able to live on the rocks, and it would completely change the ecosystem. So that's why they're really important. And we noticed this because in 2013 and 2014, there was a huge case of sea star wasting disease. And what sea star wasting disease is it essentially killed a lot of the starfish. So in certain areas it killed 75% of all the ochre stars. And they're not sure exactly why that large number happened. They think it's because a little combo of environmental factors such as increasing temperatures as well as just having the virus around that year. But something positive is that they're finding that a lot of these animals are rebounding, and they're seeing a lot of juvenile ochre stars around, so the population is increasing. So that's really good for the local ecosystems. So this is a different species of sea star. This is a leather star, and it's called that because it is, it feels like leather on the outside, and it's not spiny like the other one. And then this guy's alive, so we're gonna put him back in the water, but I just wanted to show that you can see the tube feet really well. And so along here, just like how we were talking about the ochre stars, they have their little tube feet, and that's what they use to move. So they have thousands of them, and they're able to move their bodies along quite slowly, but they're able to do it just with different their water system that they have in their body. Leather stars are different than ochre stars because they don't evert their stomach to eat. They actually eat inside their body, and so they're kind of like us. Another species we'll be looking at is the Pacific oyster, and these are part of the group Mollusca, so they're mollusks, and they have 2 articulating shells, and they're connected at the base. And these specific oysters are the Pacific oysters, and they were actually brought from Japan in the 1920s for aquaculture purposes because they're generalist species, so that means that they can grow on a lot of areas. They're pretty adaptable, they grow quite quickly, so they're really good to harvest and to eat. But something negative about that is that they pushed out the native species, the Olympic oyster. That is a little bit more specific, and it's not as hardy of a species, so there's less of them around. So these comprise about 90% of all oysters on our coast. You can tell because they have kind of frilly edges, and sometimes they're like bluish gray color. A fun fact about the oysters is that they all start off male, and as they mature, some of them switch to female, and then some of them stay male. They're filter feeders, so what that means is we're in the intertidal zone right now, so when the water goes back up, they'll open up and they'll start filtering water through their bodies. And they're looking for mainly phytoplankton, so that is kind of like the plants of the sea. They also eat zooplankton as well, so tiny, tiny animals. So you've probably seen these before if you've been to the intertidal zone. They are acorn barnacles, and acorn barnacles are part of the group Arthropoda. So they're closely related to crabs. If you can see this little guy right there, they're related to insects that are on land, and they all have a hard exoskeleton. So acorn barnacles are pretty generalist as well. They're very adaptable to the areas that they reside in. So when they're not crowded for space, they look kind of like a volcano, with the base being just as wide as the top, and they can occupy a lot more space. But when they're crowded, they're tall and thin, just like how you see here. They can reach densities of 70,000 per square meter, so that's quite a bit. They can stick a lot of barnacles in one area if it's favorable for them. They get oxygen from the air as well as the water. So when the water goes back up, they'll be able to breathe underwater. But then when the water's down for a lot of the day, like it is right now, they're also able to gather oxygen. They use their feathery legs to filter food from the water, so they're called cirri, and they stick out from the top, and they kind of grab anything that goes by and brings it into their bodies to eat. And they have 2 life stages, so you're looking at a mature, older life form, and they're sessile, so that means that they stay there for the rest of their life. But when they're younger, they can kind of float around the water column and look for somewhere good to settle, and so they move around that way. And once they've found it, they become mature and they stay there for the rest of their life. So some other bivalves that we find on the coast are clams, and so these are part of the group Mollusca again. This is a varnish clam, and so you can see by the brown coating on the edge, and this is a Pacific little neck clam, and this one's alive, so I can't open it up. It's got a little limpet on the top of it hanging out, going for a ride, and then that's the ligament that attaches it as well. So these clams are filter feeders. And so when they're under the water, they open up their shell and they're able to filter water through their body, and then they can get zooplankton and phytoplankton. They usually are found pretty deep in sand, mud, or gravel, so up to 25 centimeters depending on the species. And so they keep themselves safe that way, but sometimes they find their way to the top. And there's over 7,500 species worldwide of clams, so that's a lot of different clams. And First Nations people relied heavily on clams as a source of food, so they were a really important species for them. The last of the mollusks that we're going to talk about are the Pacific blue mussels. So these are the ones that the ochre stars really like to eat. And so they have a really neat way of attaching themselves to things. So they're attached by byssal threads. So what byssal threads are they're proteinaceous strands that the mussel can create. So kind of like how silk is created from silkworms, they create byssal threads, and then they can attach themselves to rocks. This is a really good example because there's so many different rocks all attached, so it's not attached to just one thing. It is attached to rocks like that. So again, they're mollusks and they're filter feeders as well, and they have very similar life stages to clams, but they don't bury themselves. They attach themselves to ropes and pilings. A lot of the time you'll see them in rocks as well. So this species that we're looking at is not an invertebrate, it is a seaweed. So this seaweed is called Fucus, or rockweed. It's a brown seaweed, and it grows on a lot of different areas on the coast, so I'm sure you've seen it before. It grows in wavy areas, it grows in areas with no waves. It's super adaptable to where it can grow. And it's great for different animals because it forms a canopy that protects other algae and invertebrates from wave action and from desiccation at low tide. So what desiccation means is from drying out, essentially. So it kind of protects all the other creatures from drying out. And you can see there's periwinkle snails, which are also mollusks, and they're feeding on the fucus or brown algae. So the last group that we're going to look at are cnidarians, and these ones are jellyfish. So these ones specifically are called cross jellies, and there are a lot of them in the waters off the boat right now for some reason, so we thought we'd capture some gently and then put it back in the water after, because they're really hard to shoot in the water. So they have 4 canals in a cross shape that radiate from their stomach. They're found in the light zone or photic zone close to shore from Alaska to central California. And they're bioluminescent, so that means if you tap them in the darkness, they would glow blue or green, which is pretty neat. They can grow up to 90 centimeters and have 340 tentacles. And they live from 6 to 1,600 meters deep. And they eat zooplankton. So tiny marine creatures that are zipping around in the water, these guys will eat them. But they're also eaten by other jellyfish because they're quite small. They can get bigger, but lion's mane jellies or moon jellies might eat them in the water. Thanks for watching another segment of Nature is Neat. Again, my name is Michelle and I'm a program facilitator with Power to Be. And I hope that you guys are staying safe out there, and look forward to seeing you when we get our programs up and running.